Hello, AP Calculus students out there. This is Mr. Record from Avon High School. We're going to take a look at our example 2 from our section 4.4. Maybe you've joined in and you've taken a look at our example 1. We were talking about the first fundamental theorem of calculus. We're going to stay with that idea here, but yet we're going to take a look at our good friend, the absolute value function. And I've got a lot of great help here from my 5th period class. Let's hear it, 5th period class at Avon High School. All right, there we go. So what are we going to do here? We've got the integration, the definite integral of the absolute value of 2x minus 1 from 0 to 2. Now, my particular class, and maybe some of the classes that you may be involved in if you're watching this at home, you may have seen problems like this when maybe you were studying Riemann sums, where you were finding the area under this curve, but you had to do it a little bit more geometrically, right? So, you know, I say to my class, do you remember sketching this V-shaped and finding the area under it using the triangles and whatnot? Okay, and that's certainly a viable method, and it's going to give you an exact answer. But the only problem that I personally, as a teacher, have with that, with these particular directions, is it does seem to say that it violates the idea that we're not really using the definition of absolute value, and that's what I want to try to avoid. So let's see if we can do this the way that the directions mandate. So first thing that we have to worry about is what the heck is the definition of the absolute value? Well, if you remember, that is a piecewise function, right? So we go from like our least favorite function, the absolute value, to maybe our second least favorite function, the piecewise. So the absolute value of 2x minus 1, by definition, is defined to be 2x minus 1 as long as 2x minus 1 is already positive or 0. Now, on the other hand, the absolute value of 2x minus 1 is the opposite of 2x minus 1 as long as 2x minus 1 is negative. Now, if you're bothered by this, I would probably suggest that you could watch another video. It could be one of mine, it could be somebody else's video. If you just Google definition of absolute value, you're going to find tons and tons of videos on this particular subject. I have one that I had made long ago, and I had used that for my students during the summer if they're having trouble with their summer packets. But that's where you have to sort of begin with this process. All right, so from here, where do we go? Now we can throw some calculus into this problem, right? It is a calculus problem after all. So what you're going to do is think about this. If you really want to integrate this from 0 to 2, but you're going to have to start looking at this piecewise definition, you're going to have to think about changing that boundary issue. And maybe if you're having a hard time with it, we could spend one more step and we could simplify this piecewise definition where I get the x by itself, right? So I'm just going to add 1 and divide by 2. Maybe I'll go ahead and distribute the negative in that bottom piece, and then again add 1, divide by 2, and now we have our x domain, our domain restrictions with x completely by itself. So getting back to what I was saying before, if we want to integrate and start at 0, we really have very little choice now but to stop at 1/2, because it's the value 1/2 for x where the definition of our absolute value changes. So if we're going to integrate from 0 to 1/2, my class, which piece do you think you're going to use? Top or bottom? Be the bottom piece, right? The bottom piece, because the bottom piece is the one that says, hey, I am defined when x is less than 1/2, and that's exactly what we're looking at here. So we'll place this negative 2x plus 1, right, with respect to x into that integral spot. And then you might remember, very likely if you're watching this video, you may have also been exposed to this. It's called the additive integral property that says, hey, if you want to integrate from 0 to 2, but we've already stopped at 1/2 when we started at 0, we can pick right up where we left off at 1/2 and finish it on up at 2. But obviously, we're going to be using the top piece now, right? The piece where x is defined to be greater than or equal to a half. So that would be 2x minus 1. Okay? Makes sense to everybody here? Now it's just the calculus kind of busy work approach here, right? Negative 2x plus 1 will integrate and give us negative x squared. We integrate 1, we get x, of course. And we'll use our boundaries of 1/2 and 0, right? The fundamental theorem of calculus. Again, if you're having trouble with that idea, you can go back and look at my example 1. I think I call it section 4.4, example 1. We're using the Larson textbook. When we integrate 2x minus 1, we would get x squared minus x. And the boundaries for that guy would be from 2 to 1/2. All right, and now we're going to go ahead and plug in these boundaries. The upper boundary, the upper limit, we'll plug in first. So in evaluating x for 1/2, we would get negative 1/4. Remember this negative here, right here, is not being involved in the squaring process, plus 1/2. And then we'll subtract, and then of course if we plug 0 in for x, not much is happening there, right? And then we subtract yet again. We plug in 2 for x, we would have 4 minus 2. Subtract. Let's go back here. That sign right here, I take this back. That sign is an addition, is it right? Is that right? Yeah, I'm using the sign from here. But this sign is going to be a subtraction from the fundamental theorem. And if I plug in 1/2, I'm going to look at something like that. Okay, and then when we do our work here, we find that negative 1/4 and negative 1/4 would make negative 1/2. And then the two 1/2s, which technically would be both positive, right, because of the double negative happening there, would give us a positive 1. And then these two guys would make for a 2. So altogether, I would have 3 minus 1/2, or 2.5, which is 5/2. And it turns out that if you were to sketch this graph, that's exactly what you would have. I think I could probably go in here into a calculator page just very quickly. I'm going to delete what I had before. And if I were to enter the absolute value of 2x minus 1, is that what it is? There's my sketch. And then I can use menu analyze graph integral and evaluate it. The lower boundary was 0, right? And the upper boundary was 2. And you can see that we indeed get, you can see that I screwed it up. You can see that we get 2.5 right there. I just want to make sure that I don't grab anything else but the integral. But nonetheless, that is the correct solution. So anyway, hope this helps. This is exactly the procedure that you'd want to follow anytime that you're taking the antiderivative of an absolute value. See you next time.